I can write the equation of a line given the slope and the y-intercept. Here's what you need to know. You can write any linear equation in any of these three forms, and one form may or may not be the easiest depending on which information you're given to start with. So our three forms are slope-intercept form. That looks like y equals mx plus b. And just as the name suggests, that's super useful to use when you're given the slope and the y-intercept. We also have point-slope form, which is y minus the y-coordinate equals m times x minus the x-coordinate. Point-slope form is easy when we have the slope and a point, like point and slope, or if you have 2 points because you can easily find the slope between 2 points. When we simplify point-slope form, we end up with slope-intercept form. So it just depends on the information that you're given first, which version of this equation you're going to end up with. And our last form is standard form, and that looks like this. A times x plus b times y equals c, where c is a constant value. Use this form to rewrite an equation that's already in slope-intercept form. So you would start with this form and then rearrange it to get your variables on the left side and your constant on the right side. Let's do an example. Write the equation of the line that has a slope of -4 and a y-intercept of 2. Now, it doesn't tell us which version of the equation it wants us to write this thing in. So we're just going to use the information that's given to us, that our slope is -4 and our y-intercept is +2. Since I have the slope and the intercept, let's do slope-intercept form. And that's also going to help us produce the point-slope form as well, because I can use the slope and the point 0, 2. Now this blue point, 0, 2, comes from the definition of the y-intercept. All it told us was that the y-intercept is 2. That means when my x value is 0, that's why you see a 0 right here, my y value is +2. So let's use this information and write some equations. Slope-intercept form takes on this pattern, y equals mx plus b. So we're going to put -4 in the place of m and +2 in the place of b. That's my slope-intercept form. Standard form is just the slope-intercept form rearranged to get the variables all on one side. So I'm going to use my addition property to put my 4x on the left-hand side, and I get 4x plus y equals 2. As my standard form. Same equation, it just looks a little bit different. And then point-slope form is when you take the y and the x coordinates of your point and plug them in where you see the little subscript. This y1 and x1 are the coordinates of the point 0, 2. They are not variables. The ones that are written here in the white color, those are the actual variables x and y. So I'm plugging in 2 and I'm plugging in 0. Notice that these minus signs remain because those are part of my original point-slope form. And I'm going to simplify to get y minus 2 equals -4x, and then y equals -4x plus 2 as my point-slope form. And notice that when we simplified this point-slope form, we are getting the exact same thing as our slope-intercept form. They match. You can go ahead and try this one. A weird thing obviously happened up here. That is not what that's supposed to look like. But you have your slope of 1/2 and your y-intercept of -3. Hopefully you identified those pieces correctly. Your slope-intercept form occurs when you plug in the values for m and b. Your standard form happens when you rearrange that formula. And then your point-slope form occurs after you plug in the correct pieces, but you do need to be careful when you have negative values in your points. So our y-coordinate of the point is -3. So when I plug in to evaluate, you need to make sure that you are saying -3. You're subtracting the y value minus -3. And if you look down on the next line, that becomes a +3 because the opposite of -3 is +3. And then we just rearrange And you can notice that the point-slope form is identical to our slope-intercept form. Here's another learning target. I can write the equation of a line given the slope and a point. So different information this time. Write the equation given the slope of -4 and the point 3, 1. So I know that my m value is -4, and then my x and y coordinates are 3 and 1. Since we have the slope and a point, let's use point-slope form. And plug in the values where they belong. And when we simplify, we see that our equation is y equals -4x plus 13, which is also slope-intercept form. So two birds, one stone. Once you simplify your point-slope form, you actually get it in slope-intercept form. Standard form is just this slope-intercept form that's circled in yellow, rearranged to have the variables all on one side. This should say positive 4x plus y equals 13 because we add 4x to both sides. So please ignore this negative. That should say positive 4x plus y equals 13. Go ahead and pause and try this one. When we have a slope of 3 in the point -2, 5, we're again going to try that point-slope form. We're given the slope and the point. When you plugged in the pieces where they belong, it should simplify down to be y equals 3x plus 7. Notice that that is also our slope-intercept form. When we rearrange the pieces by subtracting 3x on both sides, we get the standard form of the equation to be -3x plus y equals 7. One final learning target. You should be able to write the equation of a line given 2 points. We're going to do that here in this example. We have the points 3, 1 and 5, -2. So I'm going to identify those as two separate points. x1 and y1 are my first point. x2 and y2 are my second point. Now, in order to have the equation of a line, we must have the slope. We were given 2 points. Let's go ahead and use the point-slope form because we can plug in one of the points into this equation right here. But we also have to have the slope. Part of the point-slope form is that we have to have the point, which was given. We have 2 points. But we need to find that slope in order to fill in appropriately. So we're going to plug it into our slope formula. The change in y means I take my two y values. So I'm doing -2 and then 1, and you subtract them. And then your x values, I'm taking my 5 and my 3, subtract them. I'm simplifying to get -3/2 as my slope. So that's what I'm going to plug in for the value of m in my point-slope form. Now, it doesn't matter which of the given points you choose to plug into the equation. I'm choosing the orange point, 3, 1, to plug in the place here. So you see my 3 is my x-coordinate, my 1 is my y-coordinate, and then I'm simplifying down to get y equals -3/2 x plus 11/2. In standard form, that just means I rearrange. I'm going to add 3/2 x to both sides, and I get my standard form right here. Go ahead and pause and try this one. You're given 2 points. I'm going to call them point number 1 in orange, point number 2 in blue. We need to calculate the slope by doing our change in y divided by our change in x. We're getting that the slope is -1/2. We can plug that into our point-slope form. And again, it does not matter which of the given points you choose to plug into the equation. You will get the same answer whether you chose the orange point or the blue point to plug in. Anytime that I see a point with a 0 as one of the coordinates, I like to use that just because it makes the math a little bit simpler. When you simplify, you get that y equals -1/2 x plus 2, and we can rearrange it to produce the standard form of 1/2 x plus y equals 2. That was a lot. You made it through. If you want more on this topic, check out the Learning Target spreadsheet for additional resources, videos, and practice.